Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and today what I have for you is another explainer video. I have just finished a clean code learning program with a very interesting group, a group that really wanted to learn and wanted to practice, and we had a lot of very interesting conversations and did a lot of exercises. But one of the things that I noticed is that they were having trouble refactoring things and basically keeping the code functional at all times. And this is a principle that I have come to appreciate a lot. Keeping your product, your application running and working perfectly at all times is such a great way of developing software. It's much better than what I used to do in the beginning of my career, when I would write like 200 lines of code and then compile. It was C++, so you can imagine, and then compile and figure out what compilations error I have and fix those, and then figure out what bugs I've introduced and then fix those, and then testing things and then fix whatever else I was finding. It's so much better to have your code base always running, always ready to run. And one key pattern that you can apply in order to do this is called parallel change. This is what I like to talk about. This is an article published on 13 May 2014 on Martin Fowler's Bliki, martinfowler.com. The author is Danilo Santo, and it's talking about this pattern called parallel change, or expand and contract. And he's talking about it within or starting from a specific context, but I am using this on a lot of things. So this pattern, parallel change or the expand and contract, it's a pattern that you can use from very small things like extracting a method, even extracting a variable, or inside your code, if you have to do it manually, all the way to integration, like parallel change. One example of parallel change is we have V1, our product running. Let's install V2. Let's switch to V2 after we make sure that V2 is running properly. So that's also an expand and contract, or a parallel change. We add a new version. That's fundamentally what parallel change is. Add a new version that doesn't break anything that exists, check and make it work, and then remove the old version. It's fundamentally where it is. So the way he is talking about it is that parallel change, also known as expand and contract, is a pattern to implement backward incompatible changes to an interface in a safe manner by breaking the change into three distinct phases: expand, migrate, and contract. And he has an example here. So we have a simple grid class that stores and provides information about its cells using a pair of x and y integer coordinates. Cells are stored internally in a two-dimensional array, and clients can use the @self, #cell, and isEmpty methods to interact with the grid. And you can see in the code example, as part of refactoring, we detect that x and y are a data clump and decide to introduce a new coordinate class. So data clump is basically two variables that fit together. However, this will be a backwards incompatible change to clients of the grid class. Instead of changing all the methods and the internal data structure at once, we decide to apply the parallel change pattern. In the expand phase, you augment the interface to support both the old and the new version. In our example, we introduce a new map of coordinate and cell data structure and the new methods that can receive coordinate instances without changing the existing code. So the class grid now has both an array, two-dimensional array of cells, and a map of coordinate and cells. It allows both, it basically stores the same information twice. But this is only temporary, right? So don't be afraid. And then you have, you have an add cell that supports the old one, X, Y, and cell, which just changes the array. And then you have an add cell that has a coordinate and a cell that just changes the map. And then fetch cell, the same. You have one that receives X and Y and calls the array, returns the cell from the two-dimensional array. And you have a fetch cell that receives a coordinate and returns the cells based from the map based on the coordinate. You have an empty, so is empty and is empty. Is empty of X and Y, which uses the array, and is empty of coordinate that uses the map. And now here's the catch. Existing clients will continue to consume the old version and the new changes can be introduced incrementally without affecting them. Brilliant. During the migrate phase, you update all clients using the old version to the new version. This can be done incrementally, and in the case of external clients, this will be the longest phase. Yeah, particularly, I think this is focused on APIs. So if you're changing an API and many people are using your API, this is a brilliant way to allow them to switch to the new version. And it might take a while, depending on how many clients you have. Once all usages have been migrated to the new version, you perform the contract phase to remove the old version, the contract, okay, contract, to remove the old version and change the interface so that it only supports the new version. So now you remove everything that's using X and Y, and you just including the data member, the two-dimensional array. Now everything works. This pattern is particularly useful when practicing continuous delivery because it allows your code to be released in any of these three phases. It also lowers the risk of change by allowing you to migrate clients and to test the new version incrementally. Even when you have control over all usages of the interface, following this pattern is still useful because it prevents you from spreading breakage across the entire code base all at once. The migrate phase can be short, but it is an alternative to leaning on the compiler to find all the usages that need to be fixed. Some example applications of this pattern are refactoring, when changing a method or function signature, especially when doing a long-term refactoring, or when changing a published interface. A variant implementation of this pattern during a refactoring is to implement the old method in terms of the new API and use inline method to update all usages at once. Delegating the old method to the new method is also a way to break the migrate phase into smaller and safer steps, allowing you to change the internal implementation first before changing the exposed API to clients. This is useful when the migrate phase is longer, so you don't have to maintain two separate implementations. Database refactoring, basically the same thing. So if you want to modify, let's say you want to change some columns in your tables, you can first add the new columns, then move the data, and then remove the all columns. Deployment techniques such as canary releases and blue-green deployment, so basically what we discussed. Remote API evolution, as an alternative to specifying the version. You can use feature flags, or and you can also use branch by abstraction, which is another pattern. Quite interesting. It's a technique for making a large-scale change to a software system in a gradual way that allows you to release the system regularly while the change is still in progress. It's basically when you abstract away part of the implementation and then you branch, you implement it in a different way, and then you switch to the new implementation. With this being said, let's look at as an example. I used in the Clean Code learning program a C++ version of the elections kata. The elections kata was created by the Softwarecraft Grenoble community. And I contributed back with the C++ version because I found the exercise very interesting. Now, you can use this exercise in a number of ways, but you can use it for refactoring, or you can use it for adding new features. And in my case, I used it for extracting small objects out of bigger code to show how clean code works in terms of classes and objects. So let me show you what we can do and how parallel change would work here. First of all, we have this, we have the tests on the right and we have the code on the left. Let me run the test. I'm just running make. Tests are passing. And now if you don't know this code, which you probably don't, it's very interesting, but there's a method called, let's see which one we should take. Yeah, maybe we can start with this one. Vote for, and it receives a string elector, string candidate, string elector district, and then it goes into an if else that says if not with district else. So there's one if for in case you are voting for a candidate in a district, and another one if you are voting for a candidate outside the district or without the district. I'm not actually sure. So the tests are passing. Now, the first thing I'd like to do is to extract this code. So, because it's in many programming languages, you can do this, and your refactoring tools from your IDE will know how to do this. But in case of C++, it's often more complicated. And even if you have refactoring tools, it's always good to know how to do this manually. Anyway, because you never know what will happen. So basically what I want to do is to extract this in a method. The content of the if. This is a general thing that we try to do. So let's see if we can make some parallel change here. I'm gonna right here. I don't actually know what's happening in this method, so I'm not gonna give it a name yet. And I'm not sure what it will return. Okay. So now if we are trying to compile this, probably get a bunch of no functions named vote something. I need to go into the H file. All right. Okay, so now we compile and it tells me that candidate was not declared in the scope. Member functions, error candidate. Which candidate? Let's see. Oh, candidate. So we probably have a variable candidates. And we have a candidate. And let's see what these are. Yeah, my VS Code is not helping me much. So it's a vector of string and the string. Not the best implementation. But for now, we just go with the flow. We just extract this. So vector of string and a string. Right now it's passed by value. I don't worry about that yet. Okay, I need to go into the declaration and say vector of string and string. It probably would have been easier to write the function straight into the .h file, but we'll do it like this. It's fine. Okay, so now everything compiles, all the tests pass. Does this mean that this function is doing what it's supposed to do? Well, we don't know. And ideally at this point, you'd have some tests that verify this function. But I'm gonna play it slightly differently. I'm gonna allow for this to fail. So if this fails, we'll see what happens, because right now I'm not sure what is the output, right? So something of candidates, candidate. And this is actually a void. So I imagine it changes something. Let's just comment. Commented too much. Okay. Comment up to here. Make. Okay. Basic string construct null not valid. I think that the biggest problem is that let me try something. I think this should be a reference type. I think this can be const. Let's do a const reference. But most likely this changes. I'm gonna need to change this here. All right, and this works. And now another way I could have done this is to do this, but in the to do a return here and leave this uncommented. I'm actually curious if this works. Turn. Need to be careful with this because sometimes there's more. Oh, okay. It actually does this. So you see how I've kept both versions for a while. Now both work. I've also learned something new, which is that I can actually return from here. Yeah, and actually that makes sense because there's a there's an if else and only that. And now I have just removed. So and now I can think about a better name for this, like vote for candidate in district. Vote for candidate without district. Okay. Let's see if this worked or if my rename. Okay. This actually worked. Perfect. So to conclude, what have I done? I wanted to extract a method. How I realized that I wanted to extract a method? Well, when I see something, if and a big body, else a big body, I want to extract those as methods as a first touch. This is not the end. Once I extract those methods, I would go further and see how I can design this a little bit better. And I started by expanding. So I wrote a method, compiled it. Ideally, we would have run tests against it and see that everything is working fine. And I think that actually I could have, because I have here election without districts that could just call vote for candidate without district. And we could just see what happens. So test it. And once I'm sure, then I can, so I'm having it side by side with the old version, and then I can remove the old version. And that's how I get to making changes safe. The same thing can be applied for classes. So if I wanted to extract a class out of this, I first can create a class, let's say a class selector, write some what I expect to be in it, copy paste some of the code, and then start using it in parallel with the existing code. And after a while, merge it back and remove it, the old implementation. So parallel change, extremely powerful way of thinking. Whenever you make changes in your code and you want to keep your code running, remember that you want to keep it running and in tip-top shape at all times. And once you get into this mindset, you will find that parallel change is an extremely powerful method to do that. So if you are not using it, highly recommend it to do so. This is it for me today. I hope this is useful. Leave me a comment. Tell me how you are using parallel change, or if this was completely new to you and if you plan to use it, or if you saw this and then you try it and you have any other questions. Let me know in the comments. I like comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart.